Hi, this is Jaden Han, and this is Wylock in 7th grade, lesson 9. So the first set of problems here involves uh writing, basically writing fractions as decimals. So the way we do that is we have to divide the numerator by the denominator here. So 6 divided by 10. Well, since 6 is smaller by 10, what we have to do is move the decimal place. So we're just imagining that there's a decimal point here between 6. Even every whole number has a decimal point. It'll just be 6.000. So it'll just be repeating zeros. So that gives us some freedom. So 6.0. So we'll just have to remember there's a decimal point here. So 0 point. And then how much times does 10 go into 60? Well, then 10 goes into 60 6 times. So we just subtract 60 and we get 0. So then the answer would be negative 0.6. So let's try another one of these. It would just be dividing. It consists of dividing the numerator by the denominator. All right, let's try negative 4 and 2/10. So for this, let's first convert this into this mixed number into an improper fraction. Well, so 4, we would multiply 4 by the denominator and then add 2. So 4 times 10 is 40 plus 2 is 42. So negative 42 over 10. So now let's divide the numerator by the denominator. Okay, how many times can 10 go into 42? Well, it can go into 42 4 times. So subtract 40 and 2. So now let's imagine the decimal point here and the 0. Well, how many times can 10 go into 20? Well, that goes into 22 times. So subtract the 20 and you get left with 0. So your final answer should be negative 4.2. All right, let's move on to the next set of problems. So this one kind of consists of doing the same thing, but they gave you far more improper or fractions that are far more larger. So this one we would have to divide the numerator by the denominator. So if it's already an improper fraction where there's no mixed numbers, you just have to do that. So 8,486 divided by 10,000. Well, 8,446. 10,000 doesn't go into 8,446, so we'd have to add the decimal and the 0.0. Well, how many times can 84,460 go into 10,000? Well, it can go into 10,000 8,000 times. So once we subtract that, we're left with 446. Then we add another 0. So how many times can 10,000 go into 446? 44,600. What can go in 4 times? So subtract 40,000. So let's add another 0 here. How many times can 10,000 go into 46,000? Well, it can go 4 times. Let me just. And the reason we can keep adding these zeros is because it's a whole number. So every whole number has a 0.0000 afterwards. It's just a complete whole. So we can keep on adding these zeros until we find a decimal that works. So 60,000. How many times does 10,000 go into 60,000? Well, it goes in 6 times. So it equals 0, and we're left with 0.8446. All right, let's move on to the next set. Convert fractions to decimals using long division. So this is pretty much kind of the Actually, it's pretty much the same. Just this time we would have to long divide, but that's what we've kind of been doing. So 87 divided by 11. All right, well, we need to ask how many times can 11 go into 87? Well, it can go into 87 7 times. So let's subtract that here. So 87 minus 77 equals 10. So let's add the 0.0. So don't forget to add the point on top as well, so that you don't forget. Well, how many times can 11 go into 100? Well, 11 can go into 100 9 times. So let's subtract 99. And we're left with 1. So then we would have to add the 0 again. So how many times can 11 go into 10? Well, we can't, so let's add another 0. How many times can, and we'd have to add the 0 at top. How many times can 11 go into 100? 9. So as you can see, we're just left with a continuous cycle of just 0, 9, 0, 9. So to shorten it, let's just put 7.909. So we could put that, or if you want, you could just say 7.90 and then put a bar over it. So this bar means that it'll continue to repeat. So 7.909090. All right, let's move on to the next set. The red baton is 2.24 meters long and the blue baton is 1.16 meters long. How much longer is the red baton compared to the blue one? Well, so now we're just comparing sizes. So if the red baton is 2.24 meters long and the blue baton is 1.86 meters long, we clearly know that the red baton is larger or longer. So if we want to see how much longer it is, we just subtract the blue baton size from the red one, and we'll be just left with how much longer the red baton is. So let's regroup a little. So 4 minus 6, we couldn't do that. We would have to look at the number to our left. Well, 2.24, or 2 is not larger than 8. So let's look at the left. So we'd change the 2 into a 1, and then move the 10 to the next 2 in the tens place, and that turns into 12. and then we would borrow another 1 from the tens place and move it to the hundreds place. So we're left with this. So 14 minus 6. Well, 14 minus 6 is 8. And then 11 minus 3. Well, or 11 minus 8, that's 3. And 1 minus 1 is 0. So we would be left with 0.38. So the option is A. All right, let's move on to the next problem. Serena bought 2.5 kilograms of apples and 3 5/8 of pears. How much fruit did she buy? Well, the first thing that we should do would clearly be adding. So let's just change these into improper fractions since it's easier to add. So we would multiply 2 times 2 plus 1, that's 5.5. And then 3 times 8 plus 5, well, that's 29 8/8. So now let's change. When you're adding fractions, you need to have the same denominator. Well, the least common denominator here is 8, since it's easy to change the halves into 8s. So we just multiply the numerator and denominator of 5.5 by 4 to get 20 8s plus 29 8s. So next, let's just add them together and we get 49 8s. All right, now we just have to ask ourselves how many wholes are in this fraction. Well, 48 is equal to 4, or is equal to 8 times 6. So that means we can make 8 holes or 6 holes in here. So we'd be left with 6 1/8, and our final answer would be C. All right, that's all for today. Thank you for listening.